the groups that metals can be presented in. There are many groups that we can have what metals. We have the group 1 metals. We have the group 2 metals. You have the group 3 metals. You have the group 4 metals. And you have the transition element groups. Transition element groups. So, when you are talking about groups in the periodic table, you are talking about the vertical column that an element can be. When you are talking about the group 1, these are metals that their valency are what? 1. The group 1 metals are also called alkali metals. The group 1 metals are also called what? Alkali metals. They are called alkali metals because their hydroxide are what? Soluble in what? Water. Any substance that the hydroxide is soluble in water is called what? Alkali. So the group 1 metals are called what? Alkali what? Metals. Example, lithium. Example, sodium. Example, potassium. Alright? So when you talk about lithium hydroxide solid and you try to dissolve it in water, it is what? Soluble. It becomes lithium hydroxide what? Aqueous. Which means because lithium hydroxide is aqueous, it is what? An alkali. So it also means that lithium itself is an alkali metals. Is one of the alkali metals. Sodium also, hydroxide, is also soluble in water, which means it is sodium hydroxide aqueous. So you are going to see that the group 1 metals are called the alkali metals. The group 2 metals are called the alkaline metals, alkaline earth metals. Alkaline earth metals. And the group 2 metals have the valency of 2. Example, you have the beryllium, you have the word magnesium, you have the word calcium, you have the strontium, and you have the word barium. These are the group 2 metals. When you come to group 3 metals, the one that the valency is what? 3. You have aluminium. When you talk about the group 4 elements, the group 4 elements consist of both metals, non-metals, and what? Metalloid. But the group 4 metals are the word lead, and you also have the word tin. These are the word group 4 metals. Now, between the group 2 and the word group 3, we have another set of metals that is called what? Transition what? Elements. They are the transition elements because they occupy the D block. You have something like iron, copper, etc. They are the transition element groups. So we have seen various groups that we can see in what? Metals. Okay? Having understood this, you can also discuss the bonding that are found in the word metal. What is bonding? Bonding is that force that you can use to bind or hold the electrons in an atom. Metals have what you call metallic what? Bonding. So when you are talking about metallic bonding, in metallic bonding, you begin to see electrons inside the nucleus that have positively what? Charge. The electrons and the atom of the metals are inside a decolorized what? Nucleus. You are going to see the metallic bonding as you have a lot of nucleus, which is what? Positive what? Charge. A cloud of electron. You have the positive charge, a cloud of what? Electron. So when you now have this cloud of cations, you have the electrons, that many electrons and the atoms will be sharing this. This is what you call metallic what? Bonding. And the metallic bonding, because they have few valence electrons, most of the atoms will be sharing this, which means the atoms are also mobile and they are also free. Because of the free mobile electrons, that is what makes metals to be what? High or good conductors of what? Electricity and what? Heat. And it also gives them some other properties. So that is the bonding of a metals, and it's called what? Metallic what? Bonding. Other things we are going to see later is what you call the what? Chemical properties of what? Metals. In the chemical properties of metals, we are going to discuss many things, which I'm going to list out for now. We are going to discuss the ionization behavior of metals, ionization behavior of what? Metals. We are going to discuss again the electropositivity of metals. We are going to discuss the reducing property. We are going to discuss the action of water on metals. Action of water on what? Metals. We are going to discuss the action of acids on metals. Action of what? Acids on metals. We are going to discuss the oxides of metals. Oxide of metals. We are going to discuss the hydride of metals. We are going to look at the carbonates of metals. We are going to look at the carbonates of what? Metals. We are going to look at the nitrate of metals, the sulfate of metals, and other chemical reactions that metals can undergo. Okay? So, having seen this, which I have already listed before, that in ionization, metals ionizes by losing electrons. I've given some examples. As you talk about potassium, K, which is 3919. How many electrons does potassium has? 19. Which means the K shell will take 2. The L will take what? 8. The M will take what? 8. And the other will take what? 1. Which means when we are trying to look at potassium in the electronic configuration, you can have it as 28881. The utmost electron is 1. So when potassium wants to ionize, it's going to ionize by losing 1 electron. So because in that, we see that the ionization behavior that metals will ionize. And when they form the ionize by what? Losing an electron. If it is a group 2 metal, it's going to ionize by losing 2 electrons. Something like barium will lose 2 electrons to become this. If you have calcium, it will lose 2 electrons to become calcium ion. So based on ionization, we have seen that in the chemical property based on ionization, metals ionizes and they lose electrons while they ionize. That's the ionization behavior of what? Metals. Okay? Based on electropositivity, which is the tendency of an element to form positive ion. Metals forms positive ions. You have iron. It's a positive ion, iron 2, iron 3, chromium 3, zinc, okay, sodium. All these things are positive ions. So the tendency to form positive ions are what you call electropositivity. And metals forms positive ions, which means metals are electropositive. Now, if you talk about the reducing property, which I said that a reducing agent is a substance that donates electron during its own reaction. If you look at the reaction between maybe sodium and the word chlorine, you'll find out that sodium is the substance that will now donate an electron to what? Chlorine. Sodium is what? 281. The valency is what? 1. While chlorine is what? You have what? 8. And you have what? 7. So chlorine needed an electron is 287. Chlorine needed an electron, while sodium will donate the what? The electron. So sodium will donate an electron, while the chlorine will accept the electron. So the reaction between sodium and chlorine, because sodium donates the electron, sodium is a good reducing what? Agent. While chlorine that accepts the electron is an oxidizing what? Agent. So these are the things you can understand. Okay? You can also have based on reaction with water, which we are going to see in our next class.